So this video is going to be a quick overview of electromagnetism and electricity and free energy and Tesla stuff, and then we'll probably get into a discussion about modern technology and things like CERN, again, just for fun. But we're going to go into sort of the nooks and crannies and the untold story of electromagnetism that is sort of left out. And this is electromagnetism as Tesla understood it, and so we're going to be getting into exactly what Tesla was trying to do and maybe a little bit of rodent coil type stuff and whatnot. So first we have to go over the electrical grid as it's used today. Basically, you have some sort of energy source. You either haul an energy source in, and then you create some turbulent fluid flow, right? So you're creating current here, fluid current, with this water, this boiler, that goes and it turns a turbine. If you can find a current in nature, that's great. So that's windmills, hydroelectric dams and all that. They have basically, they're using the sun and they found a natural current here to turn the turbine. The turbine turns a series of magnets that are nested inside of a coil of wire. And this causes the current here to flow into the current here. And so this whole process here is more or less all of the electricity here is just serving as a gearbox to get this fire or this energy over here to the load on this appliance or this light bulb. So in the instance of a light bulb, and say we're burning natural gas over here, we're actually literally attempting to get the fire and the light from the natural gas into the light bulb at your house. And how do we do that? We boil the water to get artificial wind and airflow that turns a turbine. This turbine causes a sort of physical current to go through, and then this causes an electrical current. So we've turned the current of photons, basically, and heat, the radiant current, into the light current. And so this conversion process is like, I don't know, like 30%. So if you have 100 units of energy, you get like 30 of them over here to the light bulb from all the energy loss from the boiler, the turbine spinning, and then heat and resistance in the wire. And this is the foundation of the entire electrical grid. There's some nuances to it. So when you're running current through the wire, you could visualize it as electrons, but it's kind of AC current. So these things are going back and forth really fast, and that back and forth action really fast either powers your vacuum cleaner or it goes back and forth in here and generates heat and light. And that's called alternating current, which was a big thing from Tesla, because they found that with the direct current, you had a high amount of drag. So if you have direct current, which is basically when this turbine spins, it puts a continuous flow through the wire, generates a ton of resistance in the wire, and you would basically need a power plant every block or so. So Tesla invents alternating current, and we're told that this is done so that you only need a power plant for every 100 miles or more, because you can jack up the transmission distances, which is fun. And so the thing with this energy generation is that everyone kind of, basically what's happening with these motors is not doing this. This is what humans have done for a very long time, is that we paddle, or we row, and we sail. And we know that this paddling is kind of inefficient, so we mostly sail. When we're doing this electrical link up, this is more or less attempting to establish a direct mechanical linkage to the light bulb. And if you had a direct mechanical linkage from this energy source to this thing, you would have 100% efficiency. If this was just directly attached, over here, if we could somehow contain all this. And this is 100% efficiency, which is like the holy grail of energy whatevers. And the reason that this is lost is it's similar because there's some slippage. You lose a little bit of heat here, the water, it's It's like a automatic transmission of the car at each conversion step. So you're converting the heat to steam, the steam to rotational motion, the rotational motion to magnetic impulsion, and all that. And each one of these conversion processes, it's not a mechanical linkage. And since it's not a mechanical linkage, there's some slippage, and since there's some slippage, there's some friction. And so with all devices built with this mentality of electromagnetism, there's always going to be a lot of energy loss. Tesla was trying to do free energy stuff. And so what happens when you run a current through a wire is we say that it generates an electromagnetic field. And we call this the right-hand rule. So if the current's flowing this way, your right hand grabs it in the direction of the thumb, and then the current, and then the electromagnetic field will do that. And so if a charged particle comes by, it will go into that field and be influenced and altered by that field, which is how this current is being moved. These magnets sort of move and grab the electrons in a way and move them through the wire. This notion of the current generating a field is a misunderstanding, a very simplistic misunderstanding actually, and it's just one from not having a higher dimensional understanding. So this is the drag profile of a round objects in fluid, and what happens is as an object moves through fluid, it leaves these vortices behind it, and this is drag right here. So anytime that an object moves through fluids, and everything can be treated like a fluid, even solid stuff, if you zoom in on a small enough scale, it's made up of basically a fluid. It could be called quark gluon plasma or an electron cloud, but it's a cloud just as much as the water is a fluid and the air is a fluid. So everything's a fluid, and anytime that you move something through it, you get a drag profile. So when you're running current through a wire, you're actually moving all of reality in a way. Like it doesn't create the current, the wire is actually moving. And that movement generates vortices and eddies. And since it's non-physical, it's going in two non-physical dimensions. One's into the past and the future. So you get a right-hand rule, which is basically seeing it's all the current that's on we exist sort of above the water, our thinking does, and our perception thinks like up here. And when we can see something, it's kind of it's on a plane, and then as it goes through it, we see the vortices on our side of the dimensional boundary, so to speak. So that's why we have a right-hand rule. The current is actually going both directions, just like any round object moving through a fluid substance. And so that electromagnetic field is an indication and a proof that when you run a current through a wire, it changes the density of the wire so that it suddenly responds to electromagnetic energy all around us. And it's in a fluid medium, and then that drag that you see is actually the vortice as it travels through time. Those fields are our reality in the future and in the past that are influencing the way things go. So that electromagnetic field that we're seeing, the right-hand rule is the future one, and so that causes basically a rut or an eddy. Since the path has been laid down in the future, when a charged particle comes in, it follows that future. So when you run energy through an object, it moves through time. It moves through, not even time, it moves through the universe. The whole universe is a giant fluid medium, so the electromagnetic field is basically what pops up around any charged object. And anything that's moving is charged, otherwise it's not moving. Everything at every scale of existence is only moving because it's charged, and then when any charged particle moves, it has a corresponding electromagnetic field. If you wanted to really simplify that, it means that whenever any charged particle moves, it's moving through a fluid medium, and that fluid medium has basically drag and drag coefficients associated with it. There's resistance. So the whole universe is energy, and then energy moves through energy and leaves little eddies behind it, which cause little vortex and spirals. And this is why everything seems to spin in reality, because whenever anything moves through reality, it leaves vortexes behind it. So all the vortices you see anywhere are the movement that is the electromagnetic or wave movement of an object or energy. In energy, it's all one thing. And so the thinking that the current generates the electromagnetic field rather than is a product of the movement, it's basically a friction thing of the device. That's why alternating current works so well, is because it just, since you're not really trying to do anything besides link up two objects, and you're using you're kind of using the fluid medium. The way the wires work to transmit electricity is that as they connect the machine at one end to the machine at the other end, and the wire has a continuous unified current through it, it can push off the fluid things back and forth with this alternating current. And since it pushes uniformly, it transmits force. So it's actually, when you light up the whole wire with the same energy density, as that magnet like hits the wire with its field, it's basically the energy in the wire is being hit with the field of the magnet, and then that whole push, most of it, travels all the way down to the other end of the wire. But that's because it's hitting the fluid medium with a uniform pressure. And so that's just with a really simplistic current. You could see how, since it's moving through a thing, if you do an oscillating thing to where it's not just on and off, or you can play with the frequency and the amplitude of the current to generate wave-like motions and stuff in the fluid medium to actually cause less drag as you transmit the power source. And so that's what everyone has been playing around with, is the alteration of the frequency and the current, just to interact with the fluid medium in a different way to get sinusoidal waves. And that wave-like motion is basically eliminating a lot of the drag coefficient, because when you wave back and forth, you can actually pick up some of the energy lost in the spirals. So by having things coil or oscillate or anything, as they move through the fluid, they're writing their own right-hand rule or drag. They're writing their own future profile. So as they move, they're generating the future and then catching the future. It's kind of like surfing. The thing with having all of this stuff up is that, the boat metaphor, a sail, is basically anything that is sort of light enough that you can put up and suddenly it responds to a fluid medium that is different from the one that you're in. So this boat is an object that's basically part of or floating with the water. It's a physical object with the ocean, the boat. So you create a thing that can move around on the thing. This could be in the desert and on wheels, it doesn't really matter. But it's in contact with a physical object, and then you have a sail, which is capable of catching or being pulled on or will drag on a higher fluid medium up here. And then if you catch it right, like if you catch the winds right, you can basically have the boat go wherever you want. Conversely, if you wanted to, you could also stick a paddle in the water and let that drag you around, or you can use it to steer, or you can actually like pull with it. Which is one application of the electricity, is that we could be pulling with it, and that would be with a really advanced alternating current. Would let us like pull, because that's kind of, that alternating current is doing this sinusoidal thing, and that's basically swimming. So we could have very powerful paddling mechanics on our power grid that would up their efficiency. But again, it's like rowing a boat versus a sailboat. And then the way that we're trying to use the power grid now is like, basically if you've got somebody like rowing, if somebody's rowing on the boat to paddle it, and they go and they pull back and the oar is suddenly over here, we're like, this would be the power plant right here, and then we're kind of like using this motion from here to here to power the appliances. Like this back and forth motion right here, we've hooked up a light bulb and we're harvesting energy from the back and forth motion right here. And we're kind of ignoring that there's a paddle in the water. Like all of our electronic appliances, all of the wires and everything going everywhere are generating a field that's making the wire change density, so to speak, or it's making it drag on an electromagnetic fluid around it. So all the power lines are, yeah, they're moving energy back and forth, and this back and forth motion powers your vacuum cleaner and your light bulb, but it's also got a paddle in the water. All of the electrical stuff has a paddle in the water of that fluid. And so it's moving the entire boat around, not just anything that's being powered on the boat by the back and forth motion. So all of the electrical appliances and power grids and everything on Earth is actually changing the future probability cloud of the entire Earth, the same way that a sail on a boat is changing the future probability cloud of the thing. And the way that you create a sail is like with these coils. So that's why Tesla was so interested in these coils, because just like if you wanted to catch a bunch of wind, you have thread. Thread would be the sailing equivalent of a wire. You just throw up some thread into the air and you notice it gets blown that way. Okay, that's called, and we'll call wind electromagnetism. That electromagnetism moves the thread around. And then we'll notice that around the thread, when it's in the wind, it creates these little wind vortices, and we'll call that the right-hand rule. But if you weave all the thread together into a big old sheet, all of a sudden you've got a sail, because none of that field can get through it, and it pushes on it. So when you weave a nicely, densely wrapped coil, and then you turn on a frequency, or you run a current through it, it generates an electromagnetic field that other charged particles or currents cannot get through, just like a sail can't get through, or a wind can't get through the sail. At that point, then the device will be moved by that electromagnetic current the same way that a sailboat will, and it'll look like quote-unquote free energy. The thing with these devices is that you're looking at the electromagnetism around you, and you have to like basically read it like a sailor, and you have to have a device that is capable of responsive enough to catch the electromagnetic waves. Because what's going on in any fluid is relatively chaotic. This is called Brownian motion, and this is kind of like if you just dropped a particle of something in some water. This is what would happen, because the water is just jostling about and the particle just kind of randomly walks everywhere, and it's how things diffuse. So the energy in the universe at large is relatively random and relatively chaotic. But when you can sense and feel that energy, you can start to like translate it into something. You can convert it into what you want, but it's a matter of sort of catching this. And so if you can go with the Brownian motion and convert 20% of the energy at large into the direction that you want to go, like somebody throws you a bunch of energy this way and you just redirect it, that's happening all over the place. So if you get a good coil, which the human body does, the DNA wrapped in the capacitive spheres with the membrane coils of the mitochondria, these all form very excellent, mind-blowing electromagnetic sails. The mitochondrial matrix, the charged membrane inside of a mitochondria, is a coiled electrical device inside of the cells, and it can move, since it's responsive to all these like crazy minute magnetic fields suspended in a cytoskeletal element between two electromagnetic capacitive membranes. Each cell in your body harvests quite a bit of this electromagnetic energy, and that movement that it's harvesting is prana, or life, or breath. All movement, all energy moving through energy is prana and breath. And so the cells convert prana, breath, intent, movement into your energy. It's similar to eating, but less forceful. So like when you eat, you're converting wherever that energy was wanting to go, you're converting it into you to go, use for your day or what have you. So when you design a coil that is sensitive to its electromagnetic environment, it can ride the quote-unquote Brownian motion, or you might find areas of the world that have less chaotic movement, places with a current flow. That's a little bit easier to harvest the energy because it's less chaotic and less random. But if you make a coil there and you alternate the current and the frequency and stuff to ride the currents and the fields at large, so the vortices at large, if you monitor them and then come in sync with them but slightly lead them, or let them lead you, so that the device's amplitude and frequency responds to whatever the future is, which is the field that it's in, If it responds perfectly to the field, then you're going to get a ton of movement in your sail, which is going to be your coil or whatever with current running through it. You're going to get a ton of movement in there, and that movement can result in motion of the machine or extra electrical current spitting out at some other end, and that's going to look like more than 100% efficiency. And it's not free energy, and it's not more than 100% efficiency. It's just realizing that that everything is a fluid medium. So it's just a higher dimensional fluid medium, the electromagnetic field. And that field in all of our appliances today is more or less just drag, because we're moving through a fluid like with power lines that are like this and just kind of like shaking. If you look at the electrical system of the Earth, it's kind of like a nervous system having a seizure versus one that's like actually adaptive and responsive and doing anything productive or useful. And so, yeah, it's just interesting because you got to look at all the power lines are anchored, so they're dragging through a fluid. The power lines are anchoring the planet to a certain like probability stream, the same way that like an anchor thrown over into the ocean, it's like if it's dragging through the water or a sail's in the water or something like that. That's kind of what our technology is doing. From some perspectives, from other perspectives, it's assisting in cellular growth and division on a planetary process. And then you've got things like CERN, which is interesting. If you look at CERN, you have to like wonder like what sort of it's creating a field, and it's a very dense field. So it's like when you put you can catch any sort of fluid. So when you put the sail up, you catch that fluid of air. And then if you have a different density of sail, you call that a paddle, and you catch that fluid, and it changes the direction of your boat or cause certain things from the field, from it being able to interact with the field. So at CERN and these other things, they're shooting charged particles around in circles, near the speed of light. So you have to wonder what effect that sail, and that sail is embedded in the earth in a 20-mile long tunnel. So that sail's embedded in the earth and generating a very dense field. It would be tapping into, I don't know what you would want to call it, but the electromagnetic readout of moving things that fast with that much energy at that intensity is going to more or less stick a paddle or stick a sail into a very high energy current, which, like if the wind gusts too hard, you could break the mast of your sail. So it's interesting with the CERN thing is like if you stick that electromagnetic mast too deeply into the current to explore these like mysteries of electromagnetism, because they're basically exploring the mysteries of drag, like all of these fundamental particles and stuff like that. It's the same if you look at bullet pathways through, like they're just friction pathways. It's like you're throwing a particle and it goes through the water, and depending on what size and the spin and angle it has different traces as it spins through the water, and the detectors are picking up the turbulence behind the actual energy itself. Like the energy isn't the particle is even the turbulence of the thing. Like the physical body is the electromagnetic turbulence of your energy. It's behind you, the same way that these vortices are behind you, but you're in contact with them. So the body drags on your energy the same way that these vortices drag on the round object moving through a fluid. So you're in contact with your turbulence, and you can push off of it or do other stuff or be dragged by it. So it's just, it's interesting. I'm really curious to see what'll happen when CERN turns back on. And it's interesting. It's hard for me to believe that people haven't understood this about electricity for the past 100 years. So there's, or maybe not. Maybe just nobody's ever thought of this, but there's probably some sort of like insider knowledge about this electromagnetism and gravity stuff, because it's relatively straightforward when you look at it from the perspective of like fluid mechanics and whatnot, and what Tesla was doing. Like, how was Tesla able to, in his labs, to like somehow harvest enough energy to go explode the power plant down the road from putting too much energy back into the grid? He caught a big old surge with his Tesla coil, and where did it go? Back into the grid, and the plant caught on fire. so with the, the CERN thing is anchored into the Earth. So you stick that paddle way deep into the thing, and if you catch a current, a huge amount of energy might be transferred into the Earth right at that point before the machine like shuts down or the connection snaps, which would be like the ore breaking or the paddle snapping, and the intensity or the power level that machine can operate is more or less the intensity of momentary surge that could go through the thing from tapping into those deep electromagnetic fields or currents and eddies. And yeah, so, but that's a little brief overview of electromagnetism as Tesla saw it, and some other people. I think Eric Dollard understands this, and some other people are using that sinusoidal thing, but I'm not sure how many people are aware that it's the right-hand rule is basically the drag coefficient of the device. So if you could get a flexible wire that was capable of moving, and then have the power stations like have frequency and amplitude modulators along each segment, and then I'll let that wire wiggle as it transmitted power, it could very easily start adding energy back into the grid, much less a bunch of wires altogether. But they'd have to be flexible so that the motion because that electromagnetic field would move a flexible wire, right? And then that can induce current because the wire is charged and it's moving, so you get more current. Very, very simple sort of free energy device, but it would probably make a lot more sense to have flexible charged membranes like our bodies are doing. It probably makes a lot more sense to do it exactly like nature's been doing it for a really long time, rather than any of the sort of simplistic ideas that people have come up with in actuality. I don't really see how you could improve on it very much. But it's good to, it's good to know you don't know sometimes, so that you stop trying so much, because it's already being done way better.